Good morning, guys. Today is quite a short class because we're seeing one of the recurring subjects we've talked about throughout the entire year. Now, one of the things I've told you you will constantly see this year, and you've been able to confirm, is factoring and transformations. Again, the same rule that applies to linear, cubic, quadratic, and well, not exponential, but cubic, linear, and quadratic equations apply also to radicals and just rational exponents. Now, first of all, what do the graphs look like more or less? They look like this. If it is a square root or an even root, to nth root 4, 6, 8, it's going to look something like this. If it is a cubic root or an odd 5th, 7th, 9th, 11th, it's going to look like this. It is very similar to what a parabola and a cubic function work. Only that think of the rational like half a parabola that's on the side, and then if it's cubic, it's like a cubic function, but it's on the side. Instead of going up or down, it goes like this. That's pretty much what the graph should look like. Again, if you are asked to graph, and you will in the homework, you should do a table. Now, normally, we use values like negative 0, 1, 2, 3, 4, negative 4, negative 3, negative 2, negative 1 for our regular tables. Now, this is a problem with square roots. Even though you can do it, I recommend you use numbers that have actual roots. 1, 4, 9, 16. So when you plug your number into this, what is the square root of 1? 1, positive, negative. What is the square root of 4? Positive, negative 2. What is the square root of 9? Positive, negative 3. What is the square root of 16? Positive, negative 4. Because if I were to use these values to do my table, what is the square root of 2? Well, no, just plug it into a calculator and you'll get your answer. But if you do these numbers and negative, it's going to be way easier. Remember what happens to negative numbers inside square roots when they are even or odd, it changes. Okay, remember the imaginary unit. Now, after you do your table and graph, that's fine. You can just check with your calculator to confirm. The other rules, which you should know already because we've been seeing them since the first day of class, but let's go over them all, are on page 253. I'm going to go over all the rules that are on that table. Now, the first one, since it is inside the radical, you can consider it like if it were inside the parentheses. Inside the radical, left or right, and opposite. X minus 2 is 2 units to the right. If this were x plus 2, it would be 2 units to the left. Note that the radical extends and covers the 2. You have to be very careful when you write your answers. If you do this, and you meant to do this, these are two very different things. So make sure you draw the radical until you need to. Don't include anything that doesn't have to go inside, and include everything that should go inside. If you add something to the radical and it's outside the radical, it's up or down, positive up, negative down. This is a radical, it's been moved 1 unit up. If this were minus 3, it would be the exact same graph, move 3 units down. So again, inside the parentheses, left or right, and it's opposite. Negative sends you to the right, positive sends you to the left. On the outside, pluses, when you add, you go up. When you subtract, you go down. Now let's look at reflections. Again, just like in quadratics, this or this. When it's inside the parentheses, it's reflection across the y. So this would end up looking like this. When it's outside the radical, it's reflection across the x. So it would look something like this. So again, inside, reflect across the y. Outside, reflect across the x. Same thing that applies for parabolas and cubics. Just now we're using a radical instead of a parentheses. Now let's look at our horizontals and vertical shifts. And this should be Okay. These two are horizontal, these two are vertical. Now, when it's inside the radical, it's horizontal, and again, it's opposite of what you expect. This would be a horizontal shrink. This would be a horizontal shrink, horizontal stretch. When it's on the outside, a number bigger than 1 is a vertical stretch, and a number smaller than 1 is a vertical shrink. So again, we've seen all transformations. Horizontal, vertical, reflections, horizontal stretches and shrinks, vertical stretches and shrinks. That's pretty much it for today's class. It's a class we've seen pretty much every single, at least once every 2 weeks. We've seen it a whole bunch of times. Because I told you this first day of class, the rules of transformations are pretty much uniform across the board. Make sure you know them. For homework, what you're going to do is, you're going to do 9 through 10. And for 9 through 10, you do need to graph. And you do need to state the domain and range. So let's do a small review of domain and range. But let me just finish going over the exercise. So 9 through 10, you need to do a table and graph it and state the domain and range. And 19 through 26 is just describe what happens. You do not need to graph. If you graph it and then you say, Profe, pero why I graphed it? Bueno, please pay attention in the videos. You do not need to graph them. And I recommend you don't tell your friends to make sure they don't graph it, to see who actually graphs it or not, because I'm pretty sure a couple of you will graph it because you don't pay attention. But just make sure you don't graph it. And then we can have fun and laugh at the people who actually did all those graphs. So no graphing 19 to 26. Describe the transformations. It got moved 2 units up and then got vertically stretched by a factor of 3. It got reflected across the x. That's it. Just write down the transformation. Now let's go over a brief review of domain and range. Remember, domain is where your graph exists along the x-axis, and range is where your graph exists along the y-axis. Let's say, for example, I have this parabola. I know that the parabolas increase infinitely to the left and they increase infinitely to the right. So again, the domain is all real numbers. All real numbers. There are multiple ways to state the domain. You can use interval notation. All real numbers, not including negative infinity and positive infinity, because you never reach those values. You can also use set notation, but we're going to get into that in 11th grade. The first day of class of 11th grade is set notation. So you can just use interval notation, or you can also use the notations that we've seen in algebra, or you can just write all real numbers. The range is where my graph exists along the y-axis. So note, I do not exist anywhere below this value. So the range is actually between 0, including 0, and positive infinity. Or interval notation from 0 to positive infinity. That's domain and range. Domain, where I exist along the x. Range, where I exist along the y. That's pretty much it. If you have questions, let me know. This Friday, we will have an entirely practice day and video conference session if you need it. So please write down the problems that are giving you problems. Write down the problems that are giving you problems, and then we can go over them on Friday. Have a great day. Hope you guys are well. Take care.